All right, so now we get to the meat of chapter 28, and this is going to look familiar to you. Mostly chapter 28.2, this section here is review. So organolithium and organomagnesium compounds, which we've typically seen as MgBr, right? So organolithium and organomagnesium compounds express a lot of ionic character, and thus they undergo similar reactions. So both of these can be treated as if they were carbon ions, right? Recall that the electronegativity of lithium was 1.0, magnesium was 1.2, right? But you also have another electron withdrawal on the other side of it, pulling it off. So really, this is what you're dealing with. If you can see that every time, you're going to gain some serious predictive power. All right, so let's look at some examples then. We've got these before. An example of organolithium compounds are when you take an alkyl halide, and you add lithium to it. It's going to say 2 equivalents, but you know, it's if that's not there, you can assume it's 2 equivalents. Assume we are never going to add 1 equivalent. Why would we? Right? Okay. So, lithium, it's going to take 2 equivalents of it, is going to give you, really, essentially, a really good nucleophile, right? Because that's there. All right, so my wife is texting me some pictures of my son. I want to go look at those real quickly while I'm, oh, how sweet. How sweet. Nice boy. He's a fine young man. Thank you, Jill. All right, so let's go back to this. Now, this is the general. Here's a specific. And what this essentially is, watch this. 1, 2, 3, 1, 1, 2, 3, 4. And on that fourth, so one pair of electrons, you got a nucleophile. Wow. What about this? A benzene ring. Wow, I like it. Okay, same thing here. All right, so you've seen these before, just reminding you, and the reason why is because the electronegativity of lithium is very low, and so this is essentially like making a nucleophile. You've heard that before. All right, so with magnesium, you get the same thing. The same thing. Oh, by the way, I don't think I pointed this out. This is generally going to be a nonpolar solvent, like hexane. Okay, and here we're going to have a polar solvent. It doesn't say it here. It says the next slide, I think. But more importantly, really, that's more important. That's it. Well, wait, that's not it yet. It's over here. Right? That's what you're dealing with. So here, same thing, 4 carbons. Most common mistake here, folks, most common mistake is for someone to come in with, watch this. This is not a reaction, sorry. Most common mistake is for someone to come in with 5 carbons. Can you see why they would do that? These 2 are not equal. This would be 4 carbons, right? So watch out for that. It happens every semester. Lots of people fall into that trap. This is only 4 carbons. But the shape is what is tricky. Okay, so these reactions, these are all identical to the organolithium compounds. Okay, but Grignard, slightly different in the way it looks. And this, you can see, is done not in a nonpolar solvent like hexane, but this is in a polar, and importantly, aprotic. No protons around. Right, the mechanisms for formation of organolithium and magnesium are free radical beyond the scope of this course. In other words, forget about the mechanisms. Recall that for Grignard, an ether, such as diethyl ether or THF, is used. Here's your diethyl ether, THF. I think the structure of THF is here, and the name of THF is here. Okay. And the full Lewis structure of THF is here. Okay. So they're both strong bases, of course. Of course, right? Imagine what that means. If you have this guy here, he gets a chance at a proton, he gets back to happy. Look at that. Its pK is 50. In other words, it's not going to lose it. So, you know what the point is, keep it away from water. Alright, so, dumb question of the day. Is water a good solvent for the reaction between Grignard and a ketone? I say dumb question, that's a strong word. You know, it's a dumb question. It'll seem like a dumb question when you understand what the question is. So draw that out and ask yourself, is water a good solvent for the reaction between Grignard and a ketone? It might be a good idea to remind yourself what the reaction between a Grignard and a ketone is. Perfect chance to review. Okay, I think this is the last slide for this presentation. Let's review the utility of the Grignard reagent. You've seen this before. There's your Grignard. Here's a ketone or an aldehyde. And you make an alcohol, right, by following it up with water. Or you can take a Grignard and treat an epoxide with it, follow it with water, and you get an alcohol. Alright, that was chapter 13. We haven't done chapter 21 yet. There's chapter 14. We haven't done chapter 21 yet. So this will be so predictable once you get there, but right now let's skip that.